Right, we have a Bernoulli's differential equation, and we need to solve x dy dx plus y equals x squared y squared. We prepare a solution to this problem in a step-by-step manner as follows. Right. Now, first things first, we note that we have been given x dy dx plus y, which equals x squared y squared. We divide through by x, getting dy dx plus 1 over x y, which equals x y squared. Now we have transformed the differential equation into this standard form. At this point, we compare with, right, so we compare it with dy dx plus p of x, y, which equals f of x, y to the power n, which is valid for integers n, but we recommend the use when n is not 0 and when n is not 1, because when n is 0, when n is 1, this becomes a linear equation, which is very, very easy to solve, okay? And so we compare with this, but we let, at this point, we let u, right, be equal to y to the power 1 minus n. And this is enough. So after we transformed it and we compare, we can see dy dx, we can see p of x becomes 1 over x, then there is y, f of x is x, and then there's y to the power n, which is exactly y squared. At this point, we proceed to solve this differential equation in detail as follows. So at this point, by comparison, you can see that in the formula, this which is the Bernoulli's equation, there is y to the power a, and here you have y squared. So which means y would be equal to, or u would be equal to y to the power 1 minus n, and that means u is equal to y to the power 1 minus n, and this implies that u to the power 1 minus 2, and this is this. This is that. Okay. What do we do with this? We differentiate this. We differentiate this. Right. So if we differentiate these, or before we differentiate, we can make y the subject of this equation, and we write y is u to the power minus 1. And then now we can be able to get dy dx, which is dy du, du dx. Okay. This is courtesy of what you call the chain rule. Okay, chain rule of differentiation. At this point, what does this mean? It means that if we have dy dx, it equals, what is dy du? Dy du is minus u to the minus 2 du dx. Okay, so we are in business now. So wherever there is in this particular differential equation, so now we recall that we transformed it to this form here. So we actually bring that form back, and we have dy dx like this plus 1 over x y, which equals x y squared. And what is dy dx? It is minus u squared du dx. So it is minus u to the minus 2 du dx. Right, plus. So we have 1 over x. what is y equal to? Right, y is equal to u to the power minus 1, okay? So we can write that one there in the place of y, u to the power minus 1. We write that one. Right, wherever there is y, we write u to the power minus 1, which equals x. Wherever there is y, we write u to the power minus 1, and we square this. Right, and this is u to the minus 2 du dx plus 1 over x, 1 over u, which equals x u to the minus 2. We multiply through by minus u to the power 2. We multiply by minus u squared, both left and right. We get therefore du dx minus. Okay, multiplying these by minus u squared means that we have minus 1 over x u. And this is equal to minus x, like this. At this point, this is easy to solve, but very, very straightforward, because what we have is that du dx minus 1 over x u is actually equal to minus x. And then now we can be able to find what we call the integrating factor. What is the integrating factor? It is clearly e to the power the integral of the coefficient, which is minus the coefficient of u, which is minus 1 over x. And this is minus the natural log of x, which is exactly the same as x to the power. Let's first write one intermediate step here. So at this point, we can see therefore that this is e to the ln of x to the minus 1. And this is is x to the minus 1, like so. Right, so we take the x to the power minus 1, we multiply both sides, multiply each term by this. So, which means we have x to the power minus 1 du dx. Right, we multiply this one as well by x to the power minus 1. We have 1 over x u. We multiply by x to the minus 1. We have minus x, like so. Right, at this point, we have x to the minus 1 du dx minus u, which equals minus 1, okay? And this is what we have achieved so far, which means we have x to the minus 1 du dx, right? And we have minus u. Right, we have so now this would actually be x to the minus 2 u. Let me write, let's write this properly. So this will become x to the minus 2 u, which equals indeed a minus 1. Okay, so that is what we're going to have. So we have x to the minus 1 du dx, and then we have minus x. So this one is going to become exactly minus x to the minus 2 u equals minus 1. At this point, we write this as d dx of x to the power minus 1 u, which equals minus 1, like this. And this can be written as d of x to the minus 1 u, which is minus dx. So if you integrate both left and right, which is x to the minus 1 u, the integral of minus dx, what does this become? Okay, so we have achieved the integral of d of x to the minus 1 u, which equals the integral of minus dx. Okay, so this is x to the minus 1 times u minus x plus c, like this. Okay, what is the meaning of this here? We multiply through by x, both left and right. Right, giving us minus x squared plus cx. Okay, since what do we know? Since we know that y is equal to u to the power minus 1, and this then implies that y is 1 out of u, which is 1 out of what is u? U is minus x squared plus cx, like this. Okay, and this is the solution to the problem. And we have solved this problem in detail. So in other words, what is the meaning of this in other words? Okay, we conclude. Hence, if x dy dx plus y is actually equal to x squared y squared, then y is equal to 1 divided by minus x squared plus cx. And this is the answer. And we have solved this problem in detail. So thanks everybody for your time and attention, and goodbye to you.